All right, so welcome back to your favorite inorganic tutor YouTube channel once again. This episode is going to be so fantastic because we are going to talk about epsilon delta definition. Well, I know that the course is so ununderstandable, but what I'm trying to go through this process for you to get the process so easy. I want to make it so easy for everyone to understand what it means by using the epsilon delta definition to prove a limit, right? So this right here we have here, all this means is that the epsilon delta definition, what it means is that this function we have right here, right? This means that for all values of epsilon, it should be greater than 0. Epsilon doesn't take a negative number, so it must start from 0 or more, right? It must be greater than 0, right? So such that delta is also greater than 0. This statement right here, such that, means that anything that follows here, any statement that follows here is true, such that 0 is less than this function, right? It's less than what? Delta. So this means that this statement right here means that anything over here is true whenever the function minus the element must be less than epsilon, right? So nothing here is difficult, right? So let's take an example to explain this definition. Right. So this right here, they said we should prove that the limit of s cubed minus what? Y cubed all over s minus y, as s approaches 2 and 2, that is the value of x and y are 2 and 2. And then the limit is what? 12. So we are to use the epsilon delta definition to prove this, right? You can see right here that when we do direct substitution from this function, we are going to have an indeterminate solution, right? So let's try that here. S cubed minus y cubed all over x minus 3. You know, 2, 2, right? Means that x is 2, y2 is also 2. So when we do this substitution, we are going to have 8 right here and 8 also here, right? And this result will give us 0 on 0, which is what? Indeterminate, right? So we have to reduce this particular function to a polynomial function because this is a rational function. We have to reduce it to a polynomial function for us to be able to solve the problem, right? So we come up here, s cubed minus y cubed all over x minus y, right? So we want to reduce this to a polynomial function, right? So this right here is the same as x minus y, s squared plus y squared plus sy all over x minus y, right? So we can see that if we factor this s minus y multiplied by this, we are going to result at this numerator, right? So we can see that this will cancel this right here, right? So we have x squared plus y squared plus xy. So this is equal to this, right? So now we can write the limit now as lim xy approaches 2, 2 on the function right? So this is the polynomial form. So this right here, we can see that when we do direct substitution, we will result in the limit given, the 12. So let's try that out here. 2 squared, which is the x, plus y squared, which is the y, plus 2 into 2. and this right here is 12. So it has proven the limits that we were given. But we can't rely on this because a big mathematician or upgraded mathematician will challenge you and ask you why or how sure are you that if you substitute x equals 2, y equals 2 into this function, you will get 12 as x and y approaches 2 and 2. So that is where we send it to epsilon delta definition to prove it for us, right? So let's go through the epsilon delta definition. Right? So we are coming to use the epsilon delta definition to prove this, right? So we have lim as s and y approaches 2 and 2, s squared plus y squared plus sy equals 12, right? We want to use the epsilon delta to prove this, right? So first, you have to write your definition, right? So given epsilon to be greater than 0, or this right here, you can decide to write this. You can decide to write this. For all values of epsilon, it must be greater than 0, right? Then we choose delta. But how can we choose delta? For me, I can decide to say that delta is 0.00000001. But your lecturer might get mad at you because how sure are you that delta is 0.0001, right? So that is when we go through the process to justify ourselves, right? So right here, suppose 0 is less than the function that we have been given, s minus 2 all squared, y minus 2 all squared, should be less than delta, right? So we have to manipulate this function so that we have s minus 2 and y minus 2, right? So what we have right here means that s squared plus y squared plus xy, absolute of that, because we don't need negative values, right? We don't need negative values. So what we do right here is that we manipulate this to get the values that x and y are approaching. So we have right here s squared. So we add the limits to it. So f of x and y minus the limits, right? This right here should be less than epsilon, right? This right here should be less than epsilon. So we have the function which is s squared plus y squared plus xy minus 12, which is the limit that we have been given, right? This. So now we have 2, 2, right? So we have to break this 12 down so that we can have something to simplify and have these things inside there. So we have s squared minus plus y squared plus xy minus 4 minus 4 minus 4, right? Because when you break this thing down, it's still having the minus 12, right? So now we fix this here, s squared minus 4 plus y squared minus 4 plus xy minus 4, right? So let's move up. Let's move up. So when we move up, we're going to have s squared plus s squared minus 4, y squared minus 4 plus xy minus 4, right? You know, this is a difference of 2 squares. This is also a difference of 2 squares. But Right here we have xy. So we have to manipulate this so that we can have x minus 2 or y minus 2. So right here what we do is that we say x squared minus 4 plus y squared minus 4 plus xy minus 2y plus 2y. Right? We just added 0 to the xy because minus 2y plus 2y is 0. Right? So what we have here doesn't make any changes. We haven't done any changes to this. Right? So we have right here s squared minus 4. So we can say that we have 2 squared plus y squared minus 2 squared plus this xy minus 2y. We can factor y out and say x minus 2 plus 2y minus 4. Right? So right from here, we can still do, break it down, and then we can have absolute x minus 2, s plus 2, right? Plus y minus 2, y plus 2, right? And then we have right here plus y, s minus 2, plus 2. We factor 2 out, and then we have y minus 2, right? So this right here, we can still break them down because we can see that we are having delta here, we are having delta here, and we have it delta here. But we don't have s plus 2, right? So we have to break this thing down again so that we can have delta and fixing. So we have this right here is delta. So we have delta multiplied by s plus 2 plus delta multiplied by y plus 2, right? Plus y multiplied by delta plus 2 multiplied by delta, right? So this right here, we have to break this down, s plus 2, y plus 2, and then y, so that we can have x minus 2 and y minus 2 and fix it inside. So we have right here delta into s plus 4 minus 2 is the same thing. We haven't changed anything. Plus 2, s plus 2 and s plus 4 minus 2 is the same thing because when you subtract 2 from 4, we are going to result to the same thing right here. So we have plus delta into y plus 4 minus 2 plus, and this right here, y changes to y minus 2 plus 2 because if you, this is actually 0, so the actual sense is that if you add the 0 to the y, right? So this right here times delta plus 2 delta, right? So let's move up. Move up, and we have delta into s plus 4 minus 2 plus delta into y plus 4 minus 2 plus absolute y minus 2 plus 2 multiplied by delta plus 2 delta, right? So right here we can separate this, right? So we can say that we have absolute delta multiplied by s minus 2 plus 4 plus delta multiplied by y minus 2 plus 4 plus y minus 2, right? Plus 2 delta plus 2 delta, right? So this right here, we can see that we have delta into this right here tends to delta plus 4 plus delta, and this right here also tends to delta plus 4 plus delta plus 2, right? Plus 2 delta, right? So this right here, we can see that this multiplies this, and then we have delta squared plus 4 delta plus delta squared plus 4 delta plus delta squared plus 2 delta plus 2 delta, right? So we can see clearly that we have 1, we add the coefficient of the delta, right? So we have 1 plus 4 plus 1 plus 4 plus 1 plus 2 plus 2, right? So we have 5 here, 5 here, 10, 10 plus 3, 13 plus 2, and we have 15 delta, right? So we can say that we will choose a number which is also 15, so that we can clear up this 15. So we say that delta is equal to epsilon over 15. So we have delta to be epsilon over 15. Very, very good. It's so simple. You just have to follow the procedures. The idea is that the moment you finish with your assumptions, your theorems, epsilon must be greater than 0, such that now you follow up to there exists delta also greater than 0. Then such that anything that follows is true. So anything that you state down there must be true, right? Then you take your function, manipulate your function to have the function that you have been given. Make sure that whatever they give you, x approaching 2, 2, right? Manipulate it so that you can substitute the a and the b inside, right? So this right here is very simple. Thank you very much for watching. But then I want to give an alternative way to showcase this problem, right? So we have an alternative way to this problem. So as usual, our normal parameters, all values of epsilon must be greater than 0. Then you choose delta, and that is what we are interested in, right? So we suppose the function, right? The function that we are interested to manipulate, which is the s squared plus y squared plus xy, right? We can assume that we should let a equals s plus 2, right? And then b equals y plus 2, because the limit was lim of x and y approaches 2 and 2, right? So if a equals s plus 2 and then b equals y plus 2, then what we do is that wherever we see x, right? S equals a plus 2, and then y equals b plus 2, right? So wherever you see x, you put a plus 2, and then wherever you see b, you put b plus y, so you put b plus 2, right? So we have right here, this is going to be s s squared now is what? A x plus 2, and then a plus 2 all squared plus b plus 2 all squared. And then we have b plus 2 and then a plus 2, right? Minus the limit, right? So we have minus the limit. So when you do this, you'll be having a squared plus 4a plus 4 plus b squared plus 4b plus 4 plus ab plus 2b plus 2a plus 4 minus 12, right? So when you do this, you can see that we have 1, 2, 1, 2, 3, 4, right? So this will give us a squared plus b squared plus ab plus 6a plus 6b minus 12 plus 12, right? So this takes off this and we have a squared plus b squared plus ab plus 6a plus 6b, right? So this we see right here is this is 6 delta, this is 6 delta, and this is also delta, right? Delta plus delta plus delta squared, right? Because it's AB, right? So we're going to have 6 delta plus 6 delta. And this right here also is 15 delta. So we can see that an alternative way of working this problem is that delta is equal to 50, epsilon over what? 15. Very, very simple. This approach too is acceptable. If you think going through this lengthy process is going to be a problem, you can choose a variable to represent the x and then the y. Then after you do your simplification and cancel out, and then you land at your right solution. Thank you very much for watching. I really appreciate your time. Please don't forget to press on the notification bell and I'll give you more updates. Bye.